Okay, so I did number 5, which was the Richter scale one, to describe it. And when I looked at the definition of a Richter scale, it said, it was kind of hard to understand, it took me a while, but it said a numerical scale for expressing the magnitude of an earthquake on the basis of seismograph oscillations. The more destructive earthquakes typically have magnitudes between 5.5 and 8.9. The scale is logarithmic, and a difference of 1 represents an approximately 30-fold difference in magnitude. This is what got me confused, because I said the 30-fold difference, but the 30-fold difference was between the 5.5 and the 8.9. So to get from 5.5 to 8.9, it's every time you increase 1, so it'd be 5.5, and then if it was like 6.5, that would be 10 times more, the 6th one was. So from 5.5 to 8.9, it's 30. And a 30-fold, a 30-fold means 30 times more. So a 5.5 and an 8.9, the 8.9 would be 30 times more destructive, or more magnitude. So since that was kind of confusing to me, I found another definition that I kind of changed and came up with so it would be easier for me to understand. It's a base 10 logarithmic scale, which defines magnitude as a logarithm of the ratio to the amplitude to the seismic waves to a minor amplitude. That's how I figured it out. And Charles Richter came up with a formula, and the formula is M equals log I over S, which is intensity over a standard earthquake. To find the standard earthquake, it's M equals log S over S, which equals log over 1, which then equals 0. So the logs are used to make more manageable numbers to work with. Each level that you increase is 10 times stronger than the next. So if you have 7.7 and an 8.7, the 8.7 will be 10 times more than the 7.7. So to give some history, Charles Richter developed this scale in 1935 at the California Institute of Technology. He stated that the magnitude of an earthquake is determined from the logarithm of the amplitude of waves recorded by a seismograph. Each whole number increases in magnitude represents a 10-fold increase in measure of the amplitude. A 10-fold is just times 10. So this means, like I said before, each whole number you go up on the Richter scale, it's going to be 10 times more. So say you have a 6.3 and then you have an 8.3. It will be 20 times more because you go times 10 each number that you go up. So I have a graph that I found on the internet, and it says that an earthquake that is 3.5 on the Richter scale is barely felt. 3.5 to 5.9 is often felt but rarely damaged. Under 6, at most slight damage to the well-designed buildings, but can cause major damage to poorly built buildings. 6.1 to 6.9 can be destructive in areas about 10 kilometers across where people live. 7.0 to 7.9, it's a major earthquake and it caused serious damage over large areas. And an 8 or greater can cause serious damage in areas several hundred kilometers across. So an 8 or greater is really bad. And I found a few earthquakes. The biggest one was in 1960 in Chile, and it was a 9.5. And the Great Alaska earthquake in 1964 was a 9.2. The recent one that we've had in Nepal was a 7.8 on the Richter scale, and it's hard to imagine all the damage a 7.8 did what a 9.5 could do. So I have some graphs, and it's just pictures of the Richter scale, which describes like how like a magnitude 0 to 1 is represented to like grams of dynamite felt, and I'll show you. There's that, which shows what dynamite is felt. Like, it's pretty much in like representation of dynamite. Not representation, but similar being compared to dynamite. And then I actually have a picture of like a scale, and it shows like some places where it is, and it shows logarithm base of a maximum amplitude is measured in microns. There's that. And then I have another one that shows the energy waves emitted by earthquakes. There's that one. And then I have a picture of Charles Richter. Thank you.